Think about how much we rely on computers today. Whether it's texting a friend, watching a movie, checking the weather, or working from home, computers are everywhere. But have you ever stopped to wonder where it all started? Who built the first one? What made them think it was even possible? The truth is, the story of the first computer isn't just about machines. It's about war, pressure, and a few bold people who believed they could do something that had never been done before. They didn't just change technology, they changed the world. Let's count down what really happened when the first computer was built, starting at number 1010. Before machines, people were called computers. It might sound strange today, but before there were machines, the word computer referred to people. These were workers, mostly women during the early 20th century, who were hired to solve math problems. They worked long hours doing things like calculating missile trajectories and aircraft designs. This was especially true during World War II when armies needed quick and accurate data. These human computers were smart, but they were limited by how fast they could write, check, and recheck calculations. The pressure for faster solutions kept building. Scientists and military leaders started dreaming about a machine that could handle this workload, a machine that wouldn't get tired, a machine that could do in seconds what people took hours to finish. 9. War was the catalyst. The push to create the first real computer didn't come from a love of science, it came from war. During World War II, the US military had a major problem. They needed to figure out how to aim large guns accurately. Every shot fired required precise calculations that took hours to complete. By the time the math was done, the situation had often changed. To fix this, the US Army backed a project that aimed to create an electronic machine capable of solving those equations in real time. That project led to one of the most important inventions in modern history. Without the pressure of war, it might have taken decades longer to build what would become the first true computer. 8. The man who took the leap. John Mauchly in the early 1940s, a physicist named John Mauchly began to explore the idea of building an electronic calculator. He believed that using electronics rather than mechanical parts could speed up calculations dramatically. Mauchly wasn't alone in this thought, but he was one of the few who pushed hard enough to turn it into reality. He teamed up with a young engineer named Presper Eckert at the University of Pennsylvania. Together, they pitched the idea to the US Army, proposing an electronic computing machine that could calculate ballistic trajectories faster than any human. The Army gave them the green light, and in 1943, work officially began on a machine that would later be called ENIAC. 7. The birth of ENIAC stands for Electronic Numerical Integrator and Computer. It was the first general-purpose electronic computer, and it was a massive machine. It wasn't the size of a desktop, it was the size of a room. We're talking 30 tons of machinery with 18,000 vacuum tubes, 1 hours and 500 relays, and miles of wiring. ENIAC didn't look anything like the sleek laptops we use today. It had panels filled with switches and flashing lights, and programming it meant physically rerouting wires and flipping hundreds of switches, but it worked. When ENIAC was completed in 1945, it could solve problems in seconds that used to take hours. It was 1,000 times faster than any previous calculator. 6. Women were the first ENIAC programmers. One of the most surprising and often overlooked parts of this story is who made ENIAC run. While men like Mauchly and Eckert built the hardware, a group of 6 women became the very first programmers of the machine. Their names were Kay McNulty, Betty Jennings, Betty Snyder, Marlon Westkoff, Fran Bilas, and Ruth Lichterman. These women weren't given user manuals or training. They figured out how to make ENIAC work through trial and error. They mapped out equations on blackboards, broke down calculations into steps, and programmed ENIAC by hand. Their work laid the foundation for software development, even though they rarely got credit at the time. 5. ENIAC was a secret project because it was built during wartime and funded by the military. ENIAC was kept secret for years. Very few people outside the Army and the University of Pennsylvania even knew the machine existed. Security was tight, and the public didn't hear about ENIAC until it was officially unveiled in February 1946, when the press finally saw ENIAC. In action, it was treated like science fiction come to life. Headlines called it a giant brain and a lightning-fast calculator. People were stunned that a machine could process math problems with no human touch. It felt like magic, but it was real. 4. ENIAC had big problems. 2. Even though ENIAC was groundbreaking, it had plenty of issues. For one, it used vacuum tubes, which burned out regularly. If just one of its 18,000 tubes failed, the whole system could crash. Maintenance was constant, and keeping ENIAC running was a full-time job. Programming was also a challenge. It wasn't like writing code today. It required hours of physical setup, and if you made one mistake in the wiring, the entire program would fail. Plus, ENIAC couldn't store programs the way modern computers can. Every new task required a complete reconfiguration, but even with all those problems, it worked. And that was enough to spark a revolution. 3. The computer world changed overnight. Once ENIAC was revealed to the public, it set off a chain reaction. Scientists, engineers, and governments all wanted in. Suddenly, everyone saw the potential. If one machine could do the work of dozens of people, what else could computers do? Mauchly and Eckert left the university and started their own company. They went on to build the UNIVAC, the first computer designed for business use. Other teams started developing faster and more efficient machines. The race to build better computers had begun. ENIAC wasn't just a tool. It was proof that machines could think in numbers and logic. That idea was powerful enough to spark an industry that would grow faster than anyone expected. 2. ENIAC led to the digital age. ENIAC marked the transition from mechanical machines to fully electronic computing. It wasn't just about speed, it was about how information was handled. Before ENIAC, machines used gears, levers, and punch cards. ENIAC used electricity and binary logic. This shift laid the groundwork for everything we use today, from smartphones and apps to artificial intelligence and space missions. The concepts that powered ENIAC became the building blocks of modern computing. It also introduced a new way of thinking. People started to see data as something that could be stored, moved, and manipulated in ways we hadn't imagined before. It changed not just how we work, but how we think. 1. It was just the beginning. ENIAC wasn't perfect. It was huge. It was hard to program, and it broke down a lot. But none of that mattered, because it proved one thing. Computers were possible. That single idea unlocked a future filled with innovation. In just a few decades, we went from room-sized machines to pocket-sized phones with more power than ENIAC could ever dream of. What really happened when the first computer was built? A group of dreamers took a wild idea, made it real, and changed the course of history. They didn't know they were building the future. They just knew something better was possible. And thanks to them, we now live in a world where computers are a part of almost everything we do. So the next time you open your laptop or scroll through your phone, just remember, it all started with a machine full of wires and blinking lights, built during a time of war, by people who weren't afraid to try something new. The first computer wasn't just an invention, it was the spark that lit up the digital age. If you enjoyed this breakdown, hit that like button, share it with someone who loves tech history, and don't forget to subscribe for more stories that show how our world really works. Thanks for watching, and I'll see you in the next one.